Okay friends, the next part in steam nozzle is law of continuity of flow. The law of continuity equation, which is very important in thermal engineering, this is associated with the fluid flow. It states that mass rate of the mass flow rate of steam at any section of the nozzle is remaining constant. It means what? Wherever part of steam nozzle means convergent, divergent or throat section, the mass flow rate remains the same. So this is given by the equation, famous equation, m equal to a1 v1 divided by vs1 equal to a2 v2 divided by vs2, where v1 and v2 are velocity of steam at section 1 and 2. a1 and a2 are indicating area of nozzle at section 1 and 2. vs1 and vs2 indicating specific volume of a steam at section 1 and 2. So for this, whatever steam that will be getting at divergent section, which is having a different quality, so that quality is very important. We can say that this has to be studied under the condition for the steam. So condition for the steam is, the first one is, for wet steam the specific volume Vs that becomes x into Vg, where x that will be indicating the dryness fraction or quality of the steam. By knowing the dryness fraction from steam table, we can indicate this is which quality steam. Vg is the that is a specific volume of air or vapor. For dry steam, Vs equal to Vg, and for superheated steam the specific volume equal to, that becomes Vg into superheated temperature divided by saturated temperature. So this is about law of continuity equation. Law of continuity equation. And next part is effect of friction in the nozzle. The friction is the important phenomenon that will be creating a resistance against flow for any fluid. So it is a well known fact that the effect of a friction has to be studied in the isentropic devices such like nozzle. So nozzle having a convergent and divergent part through which will be indicating the entry of the steam and exit of the steam. Most probably the divergent part in a steam nozzle, which is a larger part as compared to convergent part, so that the friction probably the taken place in divergent part that compared to convergent part. So in convergent divergent nozzle, the length of the convergent portion is very small as compared to what that of divergent part. Thus the most of the friction in the nozzle occurs in a divergent part. The effect of a friction is to reduce the available enthalpy drop. The velocity of steam with the friction is given by V equal to 44 point square root of k into delta H, where k is friction factor, which is given by actual enthalpy drop divided by isentropic enthalpy drop. The effect of a friction in a nozzle that will be given by reduction in enthalpy drop. The enthalpy drop will be reduced because, as we know that the effect of a friction is that will be in divergent part, due to which velocity will be decreased. So this will be what pressure will be drop here, due to which energy will be drop, that leads to reduction in enthalpy drop. Second one, reheating of the steam, that is improving the quality of steam. As we know that in a friction there is a molecular bombardment between the surface of the nozzle and molecules of steam. So this will be creating a further reheating of the steam. Reduction in exit velocity. So as we know that, at the divergent part suddenly enthalpy drop will be occurs, due to which kinetic energy will be decreasing. So due to decrease in the kinetic energy, which will be greatly affecting the exit velocity. Next is increase in specific volume. The specific volume of a exit steam from throat section that will be goes on increasing. And decrease in mass flow rate. As we know that if specific volume will be increased, alternately the mass flow rate will be get decreased. In a friction there is a loss in energy, due to which mass flow rate will be suddenly decreased. The overall effect of a friction in a nozzle studied by HS chart or Mollier diagram or Mollier diagram. So in the figure shows that Mollier diagram, that will be uh, giving the relation between enthalpy and entropy, pressures, temperatures and dryness fraction. Along the y-axis we can take enthalpy, along the x-axis we can take the entropy. So some straight lines are there that will be indicating pressure lines and temperature lines. By knowing this HS chart or Mollier diagram, we can we can know about what effect of a friction in nozzle.